So lesson 10.6 is not really anything brand new. We're just bringing everything we learned back together. So to warm up, we'll talk about finding the sine of angle A. Sine, we just said, uses opposite and hypotenuse. If we're looking at angle A as our reference, which side is opposite? 9, and the hypotenuse is 15. So we would put 9 over 15. 9 over 15 can reduce to be 3/5. All right, number 2, the cosine of angle A. So we're still focused on angle A. Now we need adjacent and hypotenuse. What side is adjacent to angle A? 12, and the hypotenuse is still 15. That can reduce to be 4/5. Good. Finally, we want the tangent of angle A. So A is our reference. We've already identified the opposite side to be 9 and the adjacent side to be 12. 9 over 12 simplifies to be 3/4. Now they want all the same trig functions for angle B, which we could just go back to our triangle and start over with B as our reference point. Does anyone remember that the sine of B will be the same as what? Cosine of A. So sine of B and cosine of A will be the same thing. Good. Cosine of B will be the same as the sine of A. Good. So for fractions, we call that the reciprocal. So the tangents are reciprocals of each other. You could have found all those, if you don't remember the relationships, by going back to the triangle and using B as your reference point to identify opposite, adjacent, and hypotenuse all over again. When we are solving right triangles, what that means, you might want to write this or add this in your notes somewhere. Solving right triangles means that we find every side and every angle. Find every side and every angle. So that means if anything is missing, we need to find what it is. What? There are 3 sides to a triangle. And how many angles are there? 3. So that means when all is said and done, you should be able to give me 3 side measures and 3 angle measures. That's what we're doing today. All right, these notes that we're going to go through are not really anything new. This is all stuff that we've talked about and used. We're just writing it out. So it says, what if we are missing the angle measure? This is something that many people had an issue with, and I tried to be repetitive about what we need to do, so we're going to repeat it again today. If we are looking for the angle measure and given at least 2 sides of the right triangle, we can find the missing angle by using the inverse of the trig function. This should not sound new. I feel like I've said that over and over and over again. The inverse is denoted with that -1. So inverse sine is sine -1 of, in this case, they just put x. And as a reminder, for most of you, we'll have to use the shift or second key to use this function. If you still have not located the inverse sine on your calculator, let me know, or inverse cosine, inverse tangent, so that I can go over that with you. Okay, most will show the -1 exponent like above, so like the notation. Oops, sorry. All right. So on this triangle, they gave us 3 of the sides, which is nice of them. We don't have to find any sides. We are going to find both angles D and F. Okay, they told us to start with D, so we will do angle D first. You get to choose if you have all 3 of your trig functions, if you have all 3 of your sides, you get to choose which trig function to use. Okay, if they already labeled all the sides, we can use any trig function we want. Tangent. Okay, so D is our reference point, and we want to use tangent. The tangent of D is equal to what over what? Opposite over adjacent. Which side is opposite angle D? 30, and which is adjacent? 16. Now this should make it easier for us that we get options. We get to choose which trig function to use. However, some students don't like having options. They like there to be one path and only one path. So you have to get used to the fact that you just have to use whatever's given to you somehow. All right, now that we picked a trig function to use, in order to get the angle measure, we have to use the inverse. Thank you. I'm glad one person understands what we're doing here or has listened to me repeat myself a million times. To get the angle alone, we use the inverse function. If you want to reduce 30 over 16, you can. What would that reduce to? 15 over 8. If you don't want to reduce it, technically it's okay because you're putting it into a calculator anyway. Okay, and then we just have to use our calculator to take inverse tangent of 15 over 8. Anybody do that? Keon? Okay, and they want us to round it to the nearest tenth. So 61.9 degrees. Questions about how we found the measure of angle D? Okay, so if you're asked for multiple things, you should either box that in so I know that's part of your answer, or if you can write it legibly, meaning I can read it, you can put it inside the triangle where it belongs. Okay, if it's so small that I can't read it or I don't know what angle it belongs in, that won't work. But if you can fit it in there so that I can read it and I know what you're talking about, that's fine. We are also needing to find angle F. Does anyone remember how we usually went about doing this? Subtract from 180. So we take 180 minus 90 minus. Good. And what do we get for angle F? Okay. We need somebody to figure it out for us then. Thank you, Jaden. 28.1 degrees is what we get for angle F. Now at the bottom it says, what do you notice about angle D and F? We have talked about this before. What is always true about the 2 other angles in a right triangle? No, they're not congruent. They're not the same. They add up to 90 degrees. So if we take D plus F, we get 90 degrees. That will always be true in a right triangle. All right. I don't exactly like how they word these directions for example 2. Okay. Do they have the same directions on your paper? They do. So the other way that you will see directions written, like on worksheets, maybe on a quiz that's coming up soon, or a test that you might have next week, the directions might not be that long. It might just say, solve the triangle. They'll just keep it short and sweet. And what they mean when they say solve the triangle is find any and all missing sides and missing angles. How many sides are we missing? 1. They told us 2 of the sides, we're just missing 1 side. How many angles are we missing? No. 2. Which one do we already know? N is how many degrees? 90. Okay, so we are looking for 2 angles and 1 side. Let's start with angles since we just did that. That's what we're familiar with, fresh in our mind right now. P, okay. This time, we do not have a choice for a trig function because we do not know all 3 sides yet. In reference to P, let's label our sides. The side that's labeled with a 5 would be what? Opposite. The side labeled with a 10 is adjacent, and the side labeled with an N is the hypotenuse. Okay, so if we only know the opposite side and the adjacent side, which trig function do we have to use? Tangent. So the tangent of P is equal to 5 over 10. We are looking for an angle measure, which means we need to use the inverse trig function. So P is equal to the inverse tangent of 1/2. If you leave it as 5 over 10 when you type it in your calculator, it will give you the same thing. All right, so we use our calculator. We type in inverse tangent of 1/2. Good. So the measure of angle P is 26.6 degrees. You can fill that in inside the triangle if you would like. Next, let's find angle M. How do we want to do that? From? Okay, so you can either subtract from 180 or 90. If you subtract from 180, you have to subtract 90, right? 180 minus 90 minus 26.6. If you want to just subtract from 90, you only have to subtract 1 angle. So that might make it quicker. What'd you get, Jaden? 63.4. Good. Angle M is 63.4 degrees. We still have to find the hypotenuse. To solve a triangle, we have to know every single side and every single angle. We've got all the sides. Sorry, we've got all the angles. We're still missing a side. Jaden? That's a good idea. We have options again here. You can use a trig function, which is what we've been doing on our worksheets. We would set up something like the sine of 26.6 is equal to opposite over hypotenuse, right? And cross multiply and solve. Or if you know 2 sides of a right triangle, you can use a squared plus b squared equals c squared. Which would you prefer to do?
A squared plus b squared equals c squared.
Okay, are we all preferring Pythagorean theorem?
Yes.
All right, so these are our options. sounds like we would prefer to use Pythagorean theorem, which I'm fine with. So I will do that work over here on the left side. What am I putting in for A?
10
10 squared. What's going in for B?
5 squared,
5 squared. And C is
10 squared,
n squared. What is 10 squared?
100,
5 squared.
25,
100 plus 25.
125.
Now on these, since we've got a bunch of answers that are decimals anyway, if you were to just square root both sides in your calculator and give me the answer as a decimal, I'm okay with that because so many of our other answers are already decimals. Do we understand that? Okay.
I got 11.1.
Jaden, what'd you get?
11.2.
11.2.
You want us to round it or not?
Yeah, it says that.
Yeah, round to the 10th. So now we have every single side and every single angle. We want to start with the side this time. We know 2 of the sides, and right now we don't know the angles. So if all we know are 2 sides, how do we find the 3rd side? What is it, Jaden? Okay, this time the only option, if we're starting with the side, is to use a squared plus b squared equals c squared. We don't know any of the angles yet, so we can't use a trig function yet. What am I plugging in for A?
45.
45 squared. I want you to be really careful because this one gets a little weird. What are we putting in for B?
Squared.
They labeled that other leg as C.
Oh,
Okay, so we're going to put a C there. And what's going in for RC?
53.
53. Do we all understand why 53 had to go in for the C? It's the hypotenuse, it's the longest side, it's across from the right angle. Okay, it's just kind of a coincidence that their other leg was labeled with a C. It just makes it a little confusing. All right, 45 squared.
It's 2025.
2025.
Yeah.
Okay, plus c squared equals, what's 53 squared?
2,809.
2,000 or 20,000?
2,800.
809, like this?
Yeah.
Okay. How are we going to get that c alone?
Subtract.
Subtract 2025 from both sides.
784.
C squared equals 784. And then what do we do to both sides?
Square root.
Square root. And I'm fine with a decimal on these.
Oh, it's 28.
28 even?
Mm-hmm.
Oh, nice. Okay, so that side had a length of 28. We solved for the last side. Now we need to solve for both of our missing angles. Do we want to start with B or C? Okay, Jaden wants to start with B. If we know all 3 sides, we get to pick whichever trig function we want to work with.
Let's do
Sine? Okay, the sine of angle B. Sine uses which 2 sides?
Opposite.
Opposite and hypotenuse. What side is opposite angle B?
45.
45. The hypotenuse is
53.
53. If we are looking for an angle, what do we have to use? The inverse trig function. B is equal to inverse sine 45 over 53. That's when our calculators come in handy.
It's 58.1.
We agree with 58.1 degrees.
Yeah.
Okay. Last but not least, we need angle C. again, you can either use a trig function or we can subtract. You get to choose if you want to use all three angles or just subtract from 90.
31.9.
90 minus 58.1 would give us 31.9 degrees, and that is for angle C. Okay, once every single side and every single angle is labeled, that's when we know that we're done. All right, there were a few of these type of problems yesterday on that little quiz. And some people did not seem to be a big fan of them. These problems should actually be easier than some of the other ones because they've already done a lot of the work for us. They already calculated the sine of the angle. We just have to get the angle by itself. Jaden?
I did. I don't remember what I did. First one for yesterday on the quiz. I think it was.
Jaden brought up a good point. Technically, if they give you these decimals and it matches one of the decimals on your trig ratios sheet, you can work backwards from that. Okay, so if any sine has a value of 0.5 on that sheet, just go backwards and figure out what the angle for it is. If you don't understand how to do that, or you don't have your trig ratios sheet, you can use your calculator, because whenever we look for an angle, what do we use? Inverse. So you can use the cheat sheet, or you can say that A is going to be equal to inverse sine of 0.5. This is also going to be better for you if that trig value is not on your sheet. Like it's something close, but it's not exactly the same. Okay, so for the inverse sine of 0.5, what do we get?
30 degrees.
30 degrees. That one would be on your trig ratio sheet. Jaden?
The next one.
Are we ready for the next one?
Wait, did we even? Oh, that was
So on the next one, is 0.92 in our cosine column anywhere?
Yeah. Well, yeah.
Exactly or close?
Close.
Okay, so we don't want to use close. We would want it to be exact.
Oh.
So this time we should use our calculator, inverse cosine of 0.92
How do you know when you use the inverse?
when we're looking for an angle. Anytime we're trying to find an angle or degree measure, we use inverse. All right, Jaden, what is it?
23 degrees.
23 perfect?
No. Oh, round.
Rounded to the nearest tenth?
Mm-hmm.
It's 23 rounded to the nearest tenth? Okay. Oh, so it should be 23.1.
Or I might be.
Questions about number 5? All right, number 6. This time we're back to using inverse sine. Anybody figure out what A should be on the last one other than Jaden? We're looking for angle A on number 6. Shelby? 6.6. Good. 6.6 degrees.